Very good morning. Today I will discuss about the vectors for the examination of the plus two board examination. Just to discuss about the vectors. So actually first time we'll discuss what is the vector. Vector has a magnitude, or that is called a size, and direction. Magnitude as well as direction. That is called vector. Just we have seen here, that is the magnitude and direction. This is the figure of a direction, and this position is the called as the magnitude. Magnitude and as well as the direction, that is called as the vectors. The length of the line arrow shows its magnitude. That length is represent just magnitude. And the arrowed points in the direction. Arrowed points in the direction. We can add two vectors by joining them head and tail. Just we discuss, see. The first we'll discuss what is magnitude, what is direction. This is the length part only is called as the magnitude. An arrow mark represents its direction. Okay, just you see, this is the magnitude and this is directions. This length, actually this length is represent is the magnitude. Okay, this is length is represent as the magnitude, and this arrow mark is represent as the directions. So magnitude that is called as the length. Arrow mark represents its direction, right? So just we see here, we can add two vectors by joining them head to tail. And it does not matter which order we add. We get them as a result, same result. Just you can see. Two vectors are represented, A vector and another is the B vector. A vector representation you have seen here. Just you can represent here. This is the A vector. And this is B vector, A vector are in the same direction. And this is the resultant vector, and which resultant vector can be represented as the A plus B. That is also called the triangles law of vector addition. So when A vector and B vector when combined together, that is the A plus B is its resultant vectors. Okay, so we have just represent here resultant vectors, that is A plus B, and A plus B is equal to B plus A. That is satisfy the commutative property. For example, we just it is applications examples we need to show here. A plane is flying along, pointing north, but there is a wind coming from the northwest. Reality, how it is applicable, why we study them, why you study this? Because just you can see, this is a flight. A plane is flying. The plane is flying along, pointing north. Okay, but there is a wind coming from the northwest. Here represented northwest corner. This is the wind, northwest corner. This is a flight. Okay, and this is a plane, propeller, and this is wind. The two vectors, the velocity caused by the propeller and the velocity of wind, result in slightly slower ground speed heading a little east north. Just we can represent this figure. When I can see, we have previously discussed about the vector addition properties, and this is satisfy the vector addition properties. Okay, so two vectors are velocity caused and they have to add the vector addition properties. This is the figure. Subtracting, that is same procedure, triangle's law, vector addition, direction is opposite direction. First we reverse the direction of the vector, we want to subtract it. A vector, and that is B vector. This is a B vector, same direction. So opposite direction when it's moved, that is the negative of vector B considered, and that is in A minus B will come, and that is called the negative vector additions. Next, notations. How to notation? A vector is often written in the bold like A or B, or represent here A vector or B vector. Just you can see this is A vector and this is a B vector, and we can say one is head and another is tail. Or that is also a B naming vector. Direction vector is B direction. That's why this is called AB vector directions. So A vector can also be written in the letters of its head and tail with an arrow above it, like this mark. Just you can see. That is the AB vector. Just you see, that is the AB vector. Or we can say that is the AB vector additions. AB vector addition. What is AB vector addition? And just you can see, this is the figure you have seen. Okay, this is a vector here represented. Here represent A representation, and that is B representation. And this is the arrow mark is represented here, and AB. This is representation is AB vector, and this is called AB vector. AB vector in the direction of B. This is AB vector. Because one position is there, this length is the position vector, and this is the directions also. This is magnitude. Length is called as the magnitude, and arrow mark represents the direction of the vector. So this is notation of the vector. AB, then arrow mark is there. In which direction is represented? Now that is already B direction is represented. And here is also mentioned that is the B direction is represented. Calculation, how to calculate it? Now, how do we do the calculations? What is the calculation procedure? How we have to evaluate this? The most common way is to first break up vectors into X and Y parts. First we break up, one is X direction, another is Y direction. First we break up. Then this is connection is the diagonal, just represented here. AX and BY. Vector A is broken off into two vectors, that is AX and AY vectors. AX vector and AY vectors. That is AX vector. Just you can see magnitude of the directions, the AX vector and BY vector we have seen here. We mean in the vectors of magnitude and direction. But we want to see X and Y here represented this X-axis and this is Y-axis. This A vector, this is A vector, and this is resultant vector. So you can say this one is the resultant vector. Vector A in polar coordinate R and theta. So vector is polar coordinate, vector is Cartesian coordinate. When a coordinate is represented in X and Y directions, X axis and Y axis, that is called the Cartesian axis. And when it represented in the R and theta form, that is called as the polar coordinate form. Here, this is a point. This is a point X, this is X part, and this is Y part, and combined value is called XY coordinate. This combined value is called XY coordinate, and this is R and this is theta. And this is the circular form is called the polar coordinates. R theta form is called the polar coordinates, and XY is called as the polar Cartesian form. Or Rx is X is converted into polar form, that is R cos theta. X is considered as the R cos theta, Y is considered as the R sin theta in the polar form. Then R how can calculated here? Now R can be calculated in polar form. We have to see. Just we have discussed polar form. What is polar form actually? Polar form, that is x is equal to r cos theta and y is equal to r sin theta. So just you can see in when we convert it into polar form, just we can represent this x is equal to r cos theta and y is equal to r sin theta. So how to evaluate the r? Suppose x square plus y square you can evaluate. So r square cos square theta plus r square sin square theta. So just you come on the r square value and that is equal to cos square theta plus of sin square theta. So you know this is the value 1 because this is the property of the triangle, law of property. And that's the the value of 1. So x square y square, that is the magnitude of this value. And this is 1 into r square. And that is x square plus y square is equal to r square. In this Cartesian and polar coordinate relation is that x square plus y square is equal to r square. And what is the value of r? R is equal to x square plus y square root over. That is called the magnitude value of this function. Okay, are you clear? So next we can see polar form in theta. How to evaluate the theta value? Theta calculation. X is equal to r cos theta and y is equal to r sin theta, right? So just we have seen the that is r is represented x square plus y square root over, and another process to evaluate r sin theta angle by r cos theta, that is equal to y by x, and that is tan theta, and that is equal to y by x. And what is the theta? Now theta is equal to tan inverse y by x. That is the evaluating theta and r relation. Just you can say theta and relation of r. These two things are in the polar form. R theta coordinate is called polar coordinate, and xy coordinate is called as the Cartesian coordinate. We represent here r theta and polar coordinate. Just you can represent here. X is represented this, and this is r x square y square root over, and theta is called tan inverse of y by x. Same alert. This is the one example. What is combined force is collected here. So x theta r cos theta, that is also used in the various cases of application of the combined force. Okay, so this is vector addition, vector subtraction, and multiplication. So just today we'll discuss the concept of these vectors. Then we'll come just the another video will be the product, dot product, and cross product vectors, and how to apply this one, and what are the which type of question will arise in your examinations. Just we have to look out. Okay, we will see the next video. Okay, thank you.